Hey everyone, we're doing Unit 7B. This is the first topic in Unit 7B. So before starting this unit, you should have already done Unit 7A, which is practice working with exponents. So topic 1 is just the definition of an exponential function. So we just studied exponents. Now we're going to study functions that are exponential. We have recently studied linear functions, and as a reminder, we're going to start by filling in this sentence. We said, recall from previous units that a function is linear if, and what we learned last unit is if it has a constant slope. And I'm going to put one more thing here. A slope, when we look for slope, I'm going to put a little star here, and I'm going to write that the pattern is addition or subtraction, plus or minus. Alright, so now we're going to learn about exponential functions. So we're learning about exponential functions. A function is exponential if, and we're going to say something similar, but instead of the word slope, it's going to be something different. A function is exponential if it has a constant common ratio. So a common ratio basically means that the pattern is not addition or subtraction, it's multiplication or division. Alright, so we're going to look and see if we can tell whether or not a table is exponential or linear. So to do this, we are going to look at what the pattern is. So first, if you look at the x's for all of these, the x's are always increasing by 1, and you can actually see that on all the tables. So since these are always going up by 1, we're going to disregard that. We're going to look at the pattern here on the y values. So from 3 to 9, there's a couple ways to get there, but I want a constant pattern. So for instance, if I put plus 6, that pattern wouldn't hold through. So it's not plus 6. This one is going to be times 3. Because to get from 9 to 27, I do times 3, and to get from 27 to 81, I do times 3. So since it's multiplication, this is exponential, and the common ratio is 3, multiplied by 3. Alright, the next one. So we're going to go from 20 to 10, from 10 to 5, from 5 to 5 halves. Alright, so this pattern, these numbers are getting smaller. So it's definitely not multiplication since they're getting smaller. We could try subtraction, subtract 10, but that doesn't work the whole way through. So let's try division. In this pattern, if we divide by 2, divide by 2, divide by 2, that will work. So that's a pattern of division. I'm going to write here exponential. And the common ratio in this case is not 2, because 2 would mean that the numbers are getting bigger. We're going to write that the common ratio, since it's divide by 2, is 1 over 2, or 1/2. So this one is a little bit different. So with a common ratio of division, I have a fraction. Alright, last one. Let's look here at our pattern. Okay, the numbers are getting bigger. Doesn't look like multiplication here though, it looks like addition. Plus 2, plus 2, plus 2. So because it's addition, this is linear, and the slope is 2, or you could think of this as 2 over 1. Alright, so that's how you tell if something is exponential or linear. Now we're going to talk about focusing on only exponential. We're going to write two different types of equations, a recursive equation and an explicit equation. We studied these with linear. They're going to look very familiar. So a recursive equation always has two parts. It's going to start with this. F of 0 equals, and you are going to fill in this blank. What goes in this blank is the y-intercept, just like with linear. The second part always looks like this. F of x, this means to get a term, f of x, you take the previous term, which we write f of x minus 1, and then we write our pattern. So I'm going to put a multiplication symbol, and then I'm going to leave this blank. And what goes here is the common ratio. All right, let's do our explicit equation. So really, all that we need to do to answer this question is fill in this blank and fill in this blank. All right, explicit is nice and easy. This is one of my favorite equations to write. An explicit equation for exponential functions just look like this. You could write y equals, or you could write f of x equals. I'm going to write f of x equals. And then you have a number that comes first. We'll write that as letter A, parentheses, and then a letter B, close parentheses, and an exponent. So the A, the starting value, that is our y-intercept. The B, the number in the parentheses, is the common ratio. The reason the common ratio is in parentheses is because it is what we multiply by. And remember, an exponent of x means that we multiply over and over and over again. All right, so let's do an example here. This is for the exponential sequences, write a recursive and explicit rule. I'm just going to take these numbers and quickly put them in a table. X, and then we'll do f of x. And this just means this is my 0, 1, 2, 3. So 108 would come first, 36, 12, and 4. All right, so I'm going to write here that the pattern of these numbers is 108 to 36, 36 to 12, 12 to 4, is divide by 3. That means that our common ratio, and this is a tricky one, the common ratio is not 3, it is 1/3, because our pattern is division by 3. Let me make that look like a 3, 1/3. All right, the other thing that's important is let's just highlight in our table our y-intercept, 0, 108, and let's try to write these equations. So recursive always starts with this, f of 0 equals, and then we fill in the blank, like up here, with the y-intercept. Our y-intercept is 108. The next line is f of x equals f of x minus 1 times whatever our common ratio is. Our common ratio is 1/3, so times 1/3. This is our recursive equation. Put a box around it as 2 parts. Explicit equation, I use my example over here. So I'm going to start with f of x equals y-intercept comes first. Let me just erase that. Y-intercept comes first, which is 108. 108. In parentheses, my common ratio of 1/3, exponent of x. All right, next series of numbers over here. So I'm going to make a little table quickly. 0, 1, 2, 3. I have 3, 6, 12, 24. I just put these numbers, 3, 6, 12, 24, 48 here. I skipped 48 because I can already see the pattern here. 3 to 6 is times 2, times 2, times 2. So I'm going to write that my common ratio, since it's multiplied by 2, is just 2. And let's highlight our y-intercept. Our y-intercept is 0, 3, or just 3. So our recursive equation will do this. F of 0 equals 3. F of x equals f of x minus 1 times 2. That's my pattern. All right, for my explicit equation, I'll write f of x equals y-intercept comes first, common ratio goes in parentheses, exponent of x. All right, you guys should try in your homework packet, homework number 1, to practice this topic. Good luck.